Okay.
All right. Okay. All right. I'm just sharing my screen. Okay. Can you see my screen? Can you see
Yes.
my screen, guys? Yes or no? Hello?
Yes.
Oh, yes. Okay. All right. Assalamualaikum and a very good morning to all of my dynamic students. Okay. So today is the 6th of January. 2022 and it's already 10:13 a.m. Okay, so for today's class kita try to make it quick lah, and try to explain as much as you can. So we are still in topic we are in topic rigid body, but for today's class we're gonna focus on impulse and momentum. Okay, guys? Okay, impulse and momentum. So basically what we're going to do is we're gonna develop a formulation of linear and angular momentum of a body. What we're going to do is we're going to apply principle of linear impulse and momentum. And when we apply principle of linear impulse and momentum, what we're going to do is we're going to solve rigid body, uh, uh, planar kinetic problems, and we're going to solve forces, velocity, and one more is what? What we're going to do? We're going to solve velocity, forces, and one more is what? Class? We're talking about impulse. Velocity, forces. What is the other
Time.
one? Ah, yes, time. Okay. Please be alert. Okay. All right. So, in this topic, what we're going to do is we're going to use the principle of linear and angular impulse and momentum, and we're going to solve problems related to force, velocity, and time that is related to planar motion of a rigid body. Okay, but before that, what we need to do is we need to formalize and understand the method of body's linear and angular momentum. Okay, so we will go to the fundamental a bit. So linear momentum. What is linear momentum? Okay, so linear momentum is L equals to mv. Okay, with respect to G. So linear momentum is L equals to mv. Okay. So this equation, what it does is it states the body's linear momentum. Okay. And it's in a vector quantity. That's why it has m multiplied by Vg. So linear momentum, the unit, I don't know if I've mentioned to you what the unit is. The unit for linear momentum is kilogram and velocity is what? Meter per second lah. This is the unit for linear momentum. Okay, so basically it defines the direction of the direction of the velocity of the body's mass center. Okay, the direction of the velocity of the body's mass center. That is what it defines. Okay, and then another thing that I need to tell you is about angular momentum. Okay, so angular momentum, we can use the symbol H, and it is the formula is H equals to I of course G and omega. Okay, so this is angular momentum. Okay, so this equation is actually is a simplification which defines the moment of inertia of the mass with omega. Okay, so these are the two things that you need to know. Okay, now, all right. So let's go back to a little bit of the theory, which is something not you're familiar with. Okay, now, so for a rigid body, what kind of motion that can happen is first is translation. Okay, you can have translation motion. So when a body is subjected to translation motion, it can either happen in two types. What is it? I've mentioned this before. One is rectilinear, and the other one is curvilinear. Okay, we talked about this last Monday. Okay, all right. And remember, I drew you a free body diagram like this. Okay, and so since this is linear momentum, so L equals to m what? M V what? Vg, eh? Okay, so we're assuming that the velocity is this going that way, yeah? So this is the velocity, yeah? Okay, so basically, if we talk about a motion in translation, either rectilinear or curvilinear, the linear momentum can be, the formula is mvg, okay? And the angular momentum, h, what is the angular momentum? H for this example is 0. Why? Because there is no, why? Because there is no omega involved. For a motion that is moving in translation, there is no omega here. Omega is 0 here. Okay? All right. Now, okay. That is for translation. Okay. I have a video that explains about linear momentum and angular momentum. What I'll do is I will share that video, and I want you to see that video, eh? Okay, in your free time. Boleh? Okay. Okay, so next is what? Remember yesterday one is rotation. Rotation about a
Axis.
yes, fixed axis. Okay, I have a very good video on about about the difference between linear momentum and angular momentum. However, that recorded video I will give to you later lah, in a while. But I want you to look at it. That explains very clearly, what is angular momentum and linear momentum, eh. So this one is rotation about a fixed axis. I'm sure you understand already. This is the R respect to G. This is the linear momentum mvg. Okay, and H. Okay, let's say it has angular momentum. H equals to what? I omega, I omega, ig, omega. Okay, and this one, rotation about a fixed axis, it does have omega. For this one, it does have more omega. So L can be mvg, and then angular momentum can be I g omega. So for rotation about a fixed axis, this kind of example, we have the value for angular momentum. Okay, all right. And then one last example is the general plane motion lah. I'm sure you're familiar with this one lah. So general plane motion. Okay, general plane motion. Okay, it does have angular momentum, which is I g omega, and it also have linear momentum mv. Okay, all right. So for this example, for general plane motion, sometimes they can ask you to take at a not rotate about a fixed axis. It can rotate at a different point. Yeah. So let's say this is D and this is 90 degrees. D is the length lah. This is point A. For this one, the linear momentum is the same, mvg, and I'm sure you know the angular momentum H is also I g omega. Okay, it's the same thing. So you understand this. Okay, all right. So okay, now this is for the formula for linear and angular momentum, considering all the different types of motion that can happen. Okay, and of course, the next one, what do you think? Do you remember what is the formula for principle of linear impulse and momentum? Do you remember that formula? What is it? Where we learn when we learn topic particles, remember? M V
MV1
plus impulse
INC
equals to
equals to,
MV2, right?
yes,
So basically, now this is during topic particles. So now when you're considering topic rigid body, they can be what? MV1 plus what? I omega. Understand? Impulse equals to MV2 plus I omega. So this is the additional in topic what? This is the additional topic in rigid body. So this formula is linear momentum. This one is angular momentum. However, it depends on the question. Is the question moving in translation only? Then there's only MV. But if the question is rotating about an axis or there's general plane motion, do you remember what is general plane motion? They translate and rotate together, right? They translate. You remember? They translate and rotate together, kan? Combination, kan? I've told you before, kan? So when it translate and rotate, you need to consider MV1 and plus I omega. Okay? Are you okay, guys? Okay. All right. Boleh? Okay, maybe when we start doing question, yeah? Okay, so and then principle of linear impulse momentum, if you remember this one, principle of linear impulse momentum, um, so basically, first we have let me draw the diagram for principle of this one. It will be the initial momentum diagram plus what? Plus the impulse diagram. This one represent this one equals to the final momentum diagram. Okay. Okay, so there are three diagrams. So for the initial momentum diagram, okay, so this one is the final diagram. So you need to draw this diagram and these formulas. So for the initial momentum diagram, let's draw G all at the center here. Okay, so for the initial momentum diagram, you will have you can have a linear momentum. The linear momentum, what is it? M V, MVG, and you can have an angular momentum. So there will be I omega, IG omega 1. Okay, 1, 1. Okay, and then for the final momentum, it will be the same. Let's say this is M, MVG. Okay, but to differentiate, this is VG1, this is VG2 lah. Okay, and it can also have what? Angular momentum. So I G omega 2 lah. Ni omega 1. Okay, so this is the initial momentum diagram and this is the final momentum diagram. And then you will draw the impulse diagram. So the impulse diagram, we have to consider what? All the external force acting on it lah. Okay, so the external force, it can be anything lah. Let's say F1, F2, F3, these are all external forces lah. You can consider all the external forces in the question, but the external forces is in the integration of what? Time lah. You understand, guys? Time. Okay. One time is due to the time lah. Okay. Are you copying, guys? Are you okay? All right. And then the impulse diagram here, of course, boleh ada weight, kan? Ada forces, ada weight. Okay, what else? Of course akan ada couple moment, remember? Macam kita belajar on Monday hari tu. Okay, so you have to consider all the forces, either due to apa, external forces, the weight, the moment. Okay, alright. Okay, and of course the moment also must be the integration lah with time lah. Understand? And then the weight must be what? Time jugalah, T2 minus T1 lah. Biasa weight tu magnitude kan. Kalau magnitude kita terus boleh buat macam ni kan. Okay, jangan lupa all this integration is with respect with time lah. So kena ada dt kat belakang. Okay. Now, so this is the concept that you must understand. All right, and then the other thing that you must understand, this diagram, this free body diagram that you can see here, that I draw with the initial momentum diagram, impulse diagram, final momentum diagram. When you equate in the equation, you have to follow the direction. For example, MV1. This one we did an example during impulse. Okay, let's say MV1 plus I omega. Okay, but you must follow the direction. So it can be in what direction? FX. You jangan what I mean is don't equate FX and FY in one equation. Faham tak? Faham tak, guys? Okay. Takut you all buat apa tersilap. Semua campurkan dalam one equation. And then you can also have in FY direction. Okay. And of course FZ lah. Tapi kita tak go to 3D lah. Okay, kita only biasanya 2D lah. So this is the thing that you need to understand. So this is the fundamental concept lah. Okay. Alright, so number one, you must understand linear impulse momentum. What we want to do is we want to solve the velocity, force, and time. So for this kind of question, you have to understand what is linear momentum and angular momentum. This thing, I will share you a video. Okay, a video of a short video explaining what it means. Okay, and then you must understand the type of motion that can involve. It can either move in translation, it can rotate about a fixed axis, or it can have a general plane motion. And then this is the diagram that you need to draw if you have questions related to impulse and momentum lah. Okay, and then for impulse, you have to consider all the external forces, the moment, the weight that is related to that question. Okay, so are you okay, guys? Boleh? So since you are okay, do you think we can try to proceed with a question to answer related to this problem? You think we can do that? Boleh, okay. All right. Okay. Let's try to do one question, an easy question. Okay, so if you understand this, you're fine. Okay. If you rasa worried about subject dynamics, why don't you talk with your lecturers, or you can kita kan I did mention I'm going to create the talian hayat telegram kan, so just ask anything. There is no wrong questions. Okay, there is no wrong questions. You can ask anything you want. Okay, don't be shy. Okay, I'm here to help you and I want you all to pass, okay, and get an A. So I need you to and if possible, please don't do last minute asking questions. Okay, you should ask and start now. Okay, so that hati you lega, so that the anxiety when the test comes is gone. Better ask now, okay? Ini lagi like 2 hours nak exam, nak test ataupun a day before you ask all that, it's already too late. Okay, you should ask now. Okay, and you should start your project now also, because once we finish this topic, you can already start your project. Okay. Salin ni lepas tu bagi tahu after you have finished completing this question.
Dah, madam.
Dah. Alright, okay. The 10 kilogram disc is acted by a constant couple moment. So kita ada couple moment 6 Newton meter and a force 50 Newton. So ada two types lah of forces which is applied to the cord wrapped around its periphery. Okay. Determine the angular velocity. So kat sini dia nak kita determine omega berapa of the disc 2 seconds after starting from rest. So at time berapa? 2 seconds and then starting from rest. So kalau starting from rest, what do you understand? Starting from rest dia punya apa? Apa initial apa initial apa? Initial apa ni?
Angular velocity.
Initial momentum ni kosong lah. Initial momentum diagram dia kosong lah. Okay. Alright. So what are the forces component of reaction of the pin? Okay, now. So basically, let's draw the free body diagram lah. Okay, now. So how do you draw the free body diagram? Of course, you ada apa? What do you think? You because this is a pin, dia ada reaction lah. So you ada, let's say this is A point A. So you ada AX. Apa lagi you ada? AX arah tu pula. Sorry. Let's say ni point A ni point A. So arah macam ni you ada apa? AY lah. Kan? Lepas tu you ada apa? AX. Kan? Kalau ada pin macam ni, memang ini dia punya reaction lah. You ada AX and you ada AY. Lepas tu of course you akan ada apa? Apa ni? Weight lah. W Okay. Alright. So this is the what you call the free body diagram. So these are all the forces yang you kena consider into your question lah. Okay. What are the things that you need to consider into your question lah. So this is actually the what do you call that tadi? Apa? Impulse diagram lah. Okay. Let's say this is the impulse diagram, which is the free body diagram. Dia kena campur dengan apa? Dengan equals to what? Ingat tak? It's easier if you draw. Sorry, the circle is not really the same size. So this is what? The initial momentum diagram. And this is the final momentum diagram. So ni point A ni adalah point A juga. Okay, so what do you think is happening? Macam mana nak lukis? Tadi kan dah ajar macam mana nak lukis? Macam mana nak lukis? Okay, is it rotating? Guys, is it rotating?
Yes.
Kan? So dia rotating kan? So kalau dia rotating, ada apa? I omega lah. Betul tak?
Betul.
So lukislah gambar I omega, you kan dapat markah macam ni. Okay. Now, is there anything else? Is it moving? Class, is it moving? Tak kan? Dia fix at this point. There's no translation involved kan?
Yes.
Okay. So this is the diagram. So I omega 1, I omega 2. Okay. Now, let's write the equation. Okay. Now, okay. For this question, what it wants is it asks you to find what? Angular velocity. It asks you to find omega. what is omega, and then the reaction of the pin. So what do you think the reaction of the pin? Maksudnya dia nak you find AX and AY lah. The reaction of the pin lah. Okay. So macam mana you nak find that one? So kita nak guna principle of linear impulse or momentum. So you know the formula is it can be mv1 plus I omega plus apa impulse kan, impulse equals to mv2 plus I omega 2 lah. Okay, but however we have to look into the question which one is relevant and related to our question lah. Okay, since there's no translation involved, there is no what do you call a movement involved in this question, so obviously MV adalah kosong lah. But however kita kena tengok based on the direction Okay, now so first let's say kita nak buat untuk direction fx dulu. Okay, alright, kita nak buat direction horizontal dulu. I draw the direction. Let's say kita nak buat this direction, positive horizontal in that direction. Okay, for positive in that direction, for initial momentum diagram, initial impulse, kita ada tak apa-apa value? Because dia kata dia start from rest, so ni kosong lah. Betul tak? Class?
Betul.
Dia kosong lah. Okay, so any impulse in AX direction, adalah kan? So this one is going to be AX, T1, T2, what? DT lah. Betul tak? Sekejap. Biar saya buat betul-betul lah. I tulis dulu. FX, DT. Okay? Alright. Maybe wait. Maybe it's better if I do this first. Impulse ni, I tukar. I make it in this FX, DT. And then this one to be T1, T2. So in FX direction, kita ada apa? Kita ada AX lah. And the time taken is 2 seconds lah. Okay. Now, apa do you have any movement in the X direction?
No.
No. So ni pun kosong. You understand? If you draw the free body diagram, you would know. If you don't draw, you main letak je. That's why you need to draw the free body diagram. Okay. So obviously, what we can say here, what would be our answer for AX? 0 lah. So this is the answer. Okay. Alright. Tak apa. This is the first example kan. Okay. Next, let's do in the direction vertical pula. Okay. So in direction vertical, do you have anything moving in vertical? Do you have anything? Is it moving? It's also not moving, right? So kosong jugalah. Okay. Tapi you have to consider in the vertical direction lah. The forces in the vertical direction. Okay. And in the final momentum diagram, is it any movement? Tak ada kan? In the vertical direction pun tak ada. So ni kosong. Okay. So however for FYDT kita ada So kosong plus in Y direction. What do you have in Y direction? Tell me. You ada apa? AY lah. Betul tak? Let me kecilkan sikit diagram ni. What do you have? You have AY. AY kali dengan 2 second. Do you have anything else in the Y direction, guys? Ada tak? W. So, minus W 2 seconds also. Ada anything else?
F.
F. Alright, now, F2, will it be positive or negative?
Negative.
Yes. You will have F juga lah. F, sorry. Jangan lupa kali dengan 2 seconds equals to 0. Okay. So write down the equation. So you ada AY kali 2. M adalah mass. Mass dia berapa? 10 kali 9.81 kali 2. And then the force given berapa? 50 kali 2 equals to 0. So now what you can do is you can find AY. Can you tell me what is the AY answer? Ni lagi cantik kalau kita okay, what is the answer for AY? Can you quickly find for me? Dapat?
148.
Betul. 148 unit dia apa? Newton lah kan? Okay, betul. Alright, now. So you dah buat in X direction, Y direction, and the next is you need to do in you taking moment pula. Okay, let's say moment clockwise direction positive. So in clockwise direction, do you have anything apa motion, linear momentum or angular momentum? Do you have? Ada tak? Let me write this down. MV1 plus
Yes.
I omega 1 plus moment dt T1 T2 equals to MV2 plus I omega 2. Okay. So you have, what do you have? Do you have linear momentum or angular momentum? You have angular momentum kan? Betul tak? Kelas, betul tak ni? You ada angular momentum Ada I omega. Do you know why you letak I omega ni? Why? What is happening to the disc? It is being pulled by this force F and it is circling kan? Betul tak?
Betul.
Okay, I hope you understand. So for this question, you will have I omega. However, since dia kata starting from rest, what will happen to the omega 1?
Zero.
Zero. Why? Because dia starting from rest. So omega 1 is 0. Okay, now. All right. Now, what are the forces of movement that you can see in the diagram? What do you have? You have what? You have the couple moment, betul tak? 6 Newton meter, betul tak?
Betul.
Okay. So, you ada 6 Newton meter ni. Jangan lupa multiply by 2 seconds. Okay, it's positive because you consider clockwise direction positive. What else you have? Apa lagi ada?
I omega.
Belum. Apa lagi ada? Dalam
Force.
diagram ni, free body force. So you ada force F. Okay, you ada force F. Okay, force F ni positif ke negatif? Dia mesti multiply by the distance kan? So the distance, because kita taking moment dekat mana, you have to mention kita taking dekat point A. Okay. Kalau kita taking kat point A, dia 50 kali berapa?
0.2.
0.2.
Dari mana datang 0.2? Radius dia. Okay, good. Alright. So 0.2. Jangan lupa kali dengan 2 seconds. Okay. Alright. 50 ni positif ke negatif?
Positif.
Positif kan? Sebab dia ke macam ni kan? This clockwise direction dia ke arah situ kan? So dia positif. Okay. So kembali balik ke sini. Okay. Alright. Okay. Anything else? Ada lagi tak? Itu saja Okay. Equals to I omega 2. So basically untuk final momentum, final diagram ni kita ada sebab dia rotate kita adalah I omega 2 ni. So kita kena calculate I dululah. So how do you calculate I? I this. You nak pakai formula mana? 1/2 mr squared atau you nak pakai formula mk squared? Yang mana?
MR.
Ah,
Yang atas.
mr. Okay. So cuba calculate 1/2 m. Mass dia 10. R dia berapa? R 0.2 kuasa 2. So you akan dapat berapa? 0.2 kilogram the square. Okay. Okay, so I adalah 0.2 and omega 2 adalah apa yang kita nak cari lah. So from here you can find omega. So can you find me what is omega 2? What is this? This is angular velocity.
Satu enam kosong.
Okay, apa unit dia, my dear? Unit angular velocity apa?
Radius per second.
Radian per second. Good. Betul. Okay. Alright. So, itu saja untuk topik impulse and momentum. Tapi ada banyak jenis example yang berbeza yang I nak you all, yang kita kena cubalah. Okay. Yang berkaitan dengan soalan jenis yang rigid body ni lah. So, mungkin let's say saya buka sekejap Evans. Okay, so you boleh isi attendance album sekarang. So, kalau saya buka revision kit tu, mana revision kit tu? Revision kit, question. Okay, ada banyaklah soalan yang boleh buat. Okay. Okay, nampak ni? Determine the angular velocity of the pulley after 10 seconds. Ni, tu markah je. Ni, ini pun boleh dah buat dah. Ni dah boleh buat dah. Ni, ni tu second law. Ni pun rigid body. Okay. Sebenarnya nak buat soalan ni. Okay. Tak apa. You cuba dulu. You ada solution dia kan. Lagipun sekarang dah pukul 10.55. Kita tak sempat buat. Tapi by next week kita sempat lah. Kita boleh go through a little bit of maybe I pre-select lah a few questions untuk kita buat dalam kelas lah. Supaya get your momentum going ya. Okay. So boleh try lah. Dah mula-mula lah. Buat soalan yang jenis-jenis macam ni. Okay. Alright. Any questions you would like to ask? So I stop the recording.